Find the slant asymptote if it has one. So this is actually an easier problem. It doesn't say do all that other googly gobbly, so we just find the slant asymptote. And to find the slant asymptote is you divide. Now, you don't care about the remainder, so if I, for instance, just broke this apart and did something like this, I could ignore this remainder part, and I would just focus on the first part. That's supposed to be subtraction, by the way. So x squared divided by x is just x, and then of course we ignore that, right? So we just care about this part. Because we're just dividing it by a single monomial, you could just break it apart and do it this way. Might be a little easier. Anyway, so we know that we have a slant asymptote because the numerator is a 2 and the denominator is a 1. So it's one more on top. One more on top. You know, one more on top. Hopefully that makes sense. So in this case, it was a 2 over a 1. Okay, so we had a slant asymptote, and that is going to be at y is equal to x. So that is going to be my slant asymptote. Okay, and it didn't ask for anything else. We can figure out the vertical and horizontal, but it didn't ask, so I'm just going to go with the slant asymptote. Okay, let's try the next one. So we want to solve each polynomial inequality, and then graph and write the interval, graph and write in interval notation. There we go. Okay, cool. Okay, so this is a polynomial right here. It's a second degree quadratic inequality. So what we're going to do is we're going to first set it equal to 0. So first I need to get rid of that -3 on the right by adding 3, and whatever I do to one side I do to the other. That gives me x squared minus 4x plus 3 is less than or equal to 0. At that point, I've got a set equal to 0, so next step is I'm going to factor it. So square root of x squared is x, and we have ends in a positive, so they're going to match. Middle is a negative, so they're both going to be a negative. We want two numbers that we can multiply together to give you a positive 3, that if we add together, we give you a negative 4. So 1 times 3 is 3, 1 plus 3 is 4. So that works, cool. So now we are going to use the zero factor property by setting the factors equal to 0, plus 1, plus 1. So x minus 1 is equal to 0, plus 1, plus 1. Whatever you do one side, you do the other. Gives me x is equal to 1. Then we say x minus 3 is equal to 0, plus 3, plus 3. Cancel, cancel. X is equal to 3. You just flip the signs in this case pretty easily. So these are our critical points. So we can draw a number line here. We have a 1 and we have a 3. I'm not doing this to scale. I'm just trying to keep them separate enough that we can graph this fairly easily. So what I'm going to do is I'm going to test these intervals and see whether or not they make it true. So I can, for instance, plug 0 in. So for instance, I can say 0 squared minus 4 times 0, whoops, 0, is less than or equal to -3. These go away, 0 goes away, 0 goes away, so we end up with 0 is less than or equal to -3. Is 0 less than or equal to -3? No. That means that does not qualify. Now I do want to point out that this is actually a graph, right? And the intersection, it crosses it at a 1 and a 3. So what it basically looks like is something like this. Okay. Now, since I kind of know what a parabola looks like, I know this is a positive one, I know it's facing upward, and I know what I'm kind of looking for. I know that both the legs are going to match. So if this is not correct, right? If the left one is a no, then the right one must be a no, or vice versa. If the left one is a yes, then the right one must be a yes. And I also know that the bottom here is going to be on the opposite, generally speaking, right? So if the legs are yes, the dip right here is going to be a no, or vice versa, right? If the legs are no, then the dip is going to be yes, okay? So I already know pretty much like this is going to be the pattern, okay? Now I'm going to proceed to check everything, but I want to point out that if you know the pattern, what it looks like, you can kind of do this. Now the second one's not going to work that way because I don't know what this looks like. It's going to have some asymptotes. It's going to be an ugly thing. We're going to need to figure that one out doing all the steps, okay? So there are tricks to things like parabolas or things you know what they look like already. But for the other ones, you're going to have to do it the long way. So let's do it the long way, just to verify. Okay, so I'm going to pick another point. Well, there's a 2 here. This is my test point. So I did test point 0, right? So test point 0, 0. And that's what I just did. And now the next one right here, I think I'm going to do a test point 2. Okay, so let's plug a 2 in. So we say 2 squared minus 4 times 2 is less than or equal to negative 3. 2 squared is 4. Minus 4 times 2 is negative 8 is less than or equal to negative 3. 4 minus 8 is negative 4. Negative 4 less than or equal to negative 3. Check. Well, verified it. Okay, and I'm going to pick a test point. 0. We're going to pick one more than 3 or a 4. I'm going to do 4. Just as long as it's on that interval, you can pick whatever point you want. I try to pick smaller points just because it makes the math easier, but you don't have to. You can pick whatever number you want. You can pick a billion if you want to, or on the other side, you could have picked a negative trillion. I mean, you can pick crazy numbers if you want. It's just, that's just going to make your math harder, so I don't know why you would do that. Okay, so we say 4 squared is 16. Negative 4 times negative 4, or negative 4 times positive 4 is a 16. 16 minus 16 is 0. Is 0 less than or equal to negative 3? No, that is not true. And we already kind of knew that was going to happen because we already knew this was a parabola and what it kind of looked like. Okay, cool. Now, I'm going to actually shade this in because this is the part we care about. So I'm going to shade that in. In fact, I should probably use a different color just to emphasize that because I know this is very confusing looking, but we're shading that part in right there, right? So I care about that, and I care about that. Now I'm using brackets because it had inequality, right? So that's bracket. Just as a reminder, I can't spell bracket. I don't know how to spell bracket. So that just means we're going to use brackets. Or bracket. I don't know. Anyways. Okay. So this one's a little bit different. Because this one actually makes something undefined in the denominator, I'm going to set it equal to 0 and solve. And that will give me one of the critical points right off the bat, right? So I know I have a critical point right there. That's one of my critical points. Now at that point, I'm actually going to multiply and get rid of it. There is another way of doing this. I think that the book is going to show you the other way. That's fine. You can do it the other way if that makes sense to you. But I just like to get rid of it once I get the information out of it. Okay, and what I end up with is negative x plus 2 is greater than or equal to 0. Okay, so I finish solving this. I put plus x, cancel, cancel. And that gives me 2 is greater than or equal to x. Cool. Okay, so those are my critical points. So I found critical point. Critical points. So there's that, and there's that. Okay, cool. So 4 and a 2. So I draw my long number line right here. Put a 0 right here just for a place. Have a 2, and I have my 4. I know that's not proportional. I'm just trying to spread them out so I can easily write some stuff. Okay, cool. So my test point 0. Test point 0. I don't exactly know why I put 0 instead of the number I wrote it out, but whatever. Okay, so we plug a 0 into this one. So we say negative 0 plus 2 over 0 minus 4. All right, so that gives me a 2 over a negative 4, which would give me a 1, right? A negative 1 over 2, or a negative 1/2. All right, negative 1/2. Now that is supposed to be greater than or equal to 0. Is negative 1/2 greater than or equal to 0? You would say yes. So that first part test it out. I'm going to do a test point 3. So test, I'm just going to put test 3. Okay, we're going to try that one right there. So I'm going to put a negative 3 plus 2 over a 3 minus 4. And that's greater than or equal to 0. So negative 3 plus 2 is negative 1. 3 minus 4 is negative 1. Negative 1 over negative 1 is 1. You say 1 is greater than or equal to 0. Yes, that is also true. So I plugged it into 0 originally. I'm going to double check that. 0. So we have a 2 on top, 0. We have, oh, no. Hold on. I put 0 is, negative 1/2 is greater than or equal to 0. Sorry, I'm tired. No, that was actually fine so far. Let's see. Okay, obviously that is not true. Negative 1/2 is not, in fact, greater than or equal to 0. Don't know what I was thinking. Okay, and we do another test point over here. It has to be greater than 4, so I'm just going to pick a 5. So test, I'm going to do test the 5. So we plug it in. So negative 5 plus 2 over 5 minus 4. So, and that's greater than or equal to 0. So negative 5 plus 2 is a negative 3. 5 minus 4 is a 1, so we end up with negative 3. So is, in fact, a negative 3 greater than or equal to 0? And we would say, no, it is not. So we are only interested in that part in between these. So we're interested in here and here, and we just shaded it. Okay. Now, what I did not do in either of these cases is write it in interval notation. I did graph it. All you do is you basically just rewrite from what you have right there as a 1, a 3, and in this case I'm going to have a bracket on both sides. And in this case, this is a little bit different. I need to change the one I got from the denominator, that the 4, that is not going to in fact be a bracket. That is going to be a parenthesis because it cannot be equal to that. So we do not include 4. So because this, right, cannot be equal, because of that, that's a parenthesis. Parenthesis. I don't know how to spell parenthesis. We'll just say parenthesis, whatever. Okay, now the other one is going to be a bracket, which I can also for some reason not spell. Just bear with me. Bracket. Sure, why not? That looks good enough. I can do the math, I just can't spell. Okay, so we have this. Now you see how I graphed it on there? We're just going to rewrite that, and that is actually going to turn into our interval notation. So that's the graph, and from the graph we can easily derive the interval notation, right? So we just plug the numbers inside of whatever the shaded and the brackets or the parentheses look like. We just stick the numbers inside of it, and we get our interval notation.